All right, let's take a look at today's lesson. So today's lesson is about slope fields. Um, that sounds weird, right? Slope fields. But this is a picture of a slope field. So what are all those little lines? Those little lines are like tiny little tangent lines. They really describe or a visual picture of what the slope looks like at that location. Like if we were to, look right here. So the slope at, the point 1, 0 would be around, I don't know, whatever that would be. That's more than one, maybe 2 or 3, a slope of 2 or 3. So how do they help us? What do they do? So the reason we have slope fields, or one of the reasons, is it's a good visual picture of what our position would look like. Okay, so let's go through some vocabulary. So we know that a differential equation, when we solve a differential equation, that means find the position, right? That means do the antiderivative and find the position. That's what solving a differential equation means. And for whatever reason, this business of solving differential equations is confusing. That can be confusing. What does that mean? That means that I integrate and I get the position. So sometimes, actually many times, it is impossible to integrate, things by hand. It's impossible. So this is one estimation technique that we have as, to look at what would the position look like? What would it look like? Okay, so that's basically one of the reasons that we do slope fields. And there's a lot of different, things that we will encounter with slope fields. Sometimes we'll draw them, like on number 1 and 2. We're going to actually draw the slope field. And then we'd have other things that we do with them, which I'll show you in the next, all the next questions. So let's this first is just a picture. If I were to, this differential equation just actually has an x in it, which, may be weird. I don't know. So if we want to see what happens when x is 1, when x is 1, then dy dx would be 2, right? I want you to understand what the slope field is for. So we're just going to talk through this. When when x is 1, dy dx is 2. So if we look here, everywhere that x is 1, we see that slope. So that slope is 2. Now a computer generated that, so that's actually, that slope is 2. When we do them by hand, we're just estimating, so it's not going to be as precise as a computer, but the computer, that's the slope of 2. So that's what this graph represents. It represents little baby tangent lines, if you will. Okay, so the first question we're going to work through is we're going to actually create a slope field. We're given the differential equation and we're going to create the slope field. Okay, so what do? This is what I would recommend. I typically do a triple T chart. And we're looking for patterns. We're hoping to find patterns, right? So we've got like x here and y here and dy dx here. All right, so what we're required to do is everywhere we see a dot, we need to put a little line there, a little slope line there. Everywhere there's a dot. Okay, that's our requirement. And so there's actually a lot of dots here. Typically on the AP test, we might not have quite that many, but we can do this. So if I look at the point 0, 0, and I do 0 times 0, that would be 0, right? And so I need a slope of 0 right here. So I just make a slope of 0. And maybe we'll just do a different color so it shows up. So there's my slope of 0. All right, so let's think about this for a second. Let's see, it would help us if we could determine a pattern so that we don't have to do, there's a lot of points here. There's a lot. I'd have a whole big long list. If I can figure out a pattern, then I can go ahead and fill in I don't know. So this x-axis, on the x-axis is where y is 0, right? And so when y is 0, what is my slope going to be? It's going to be 0, right? 0 times anything is 0. So I can actually populate this whole line with that pattern, knowing that when y is 0, that whole differential equation is going to be 0. Any other thoughts? What else? What about when x is 0? Do I know anything about that? They're all going to be 0. So when x is 0, which is the y-axis, they're all going to be 0. So I can go ahead pretty quickly and populate all of those spots. That makes me very happy. I've gotten, a lot of those without a whole lot of time. Okay, so now let's look and see what happens when we have a point of 1, 1. What happens? It would be 1 times 1, which would be 1. So at 1, 1, that slope is 1. And that one I think is one of the easiest ones to do because it's like a 45. It's like we know it's like the line y equals x, right? A slope of 1 is pretty straightforward. It's not straight up. It's not, horizontal. It's right in the middle, like at 45 degrees. Okay, so let's see. So what about negative 1 times negative 1? What about right here? Won't that also be 1? Okay, so I can do that. Let's go back to our, and that this, let me just explain. This right here is for your benefit only. I'm not going to grade that. In fact, if you don't want to write that at all, that's fine. I just kind of want a place where I can write my thoughts on what's going on. But you don't have to do a T-chart. You can just do it in your head if you prefer. Let's look and see what happens at 2, 1. So 2, 1, it would be 2 times 1, which would be 2. So the important thing about drawing, like a slope of 2 is much harder than a slope of 1. What we need to do is we just need to make sure that this slope line is slightly steeper than this one. We just need it to be a comparison. Okay, we don't have to be perfect, but I just really want it to look a little steeper than the one right next to it. Just a little steeper. So when your slope fields are being scored, that's what we look at to see what they look like in relation to each other. Okay? All right, then I've got 1, 2. This one is going to have the same slope, right? 1, 2 would have this same slope, would be 2. Okay, what about 2, 2? 2 times 2, 2 times 2, that would be 4. So this is even going to be steeper. So we're just going to make it steeper. All right, are we getting the hang of it? Some people love these. They love drawing slope fields, and some people are like, oh, this is the most worst thing I've ever done in my life. I don't know, but if you compare this to maybe optimization, maybe you might pick slope fields. I don't know. I don't know. So here we go. So let's look at, we've got negative 1, 1. Let's go over here to this location, negative 1, 1, right here. Negative 1, 1 would give me a slope of negative 1, and that would be like negative 1. Okay. All right. What about, we see, where would another negative 1 be? Would there be another negative 1 in the fourth quadrant? Wouldn't there at 1, negative 1? Right here? Okay. All right. So let's see what we have now. So let's try negative 1, 2. So we're looking right up here, negative 1, 2. And negative 1, 2 would be what? Negative 2. So I'm going to have a steeper slope than the negative 1. Okay, so let's keep going. So we've got negative 2, 1 will give me negative 2. So I don't like that. A little bit steeper. And then negative 2 times 2 is negative 4, so that would be even steeper. Is everybody okay? Okay, we have a few more points to do, so let's do what? -2, -1. -2, -1 would be 2. So that's just a little steeper than the -1. Okay, we getting the hang of it? Okay, so -1 times I'm going to work on this point right here. -1 times -2 would be 2, so kind of like that. And then -2 times -2 is, I'm going to make that a little, -4, which is steeper. Okay, 3 more points. We're almost there. Okay, 2 times, so we have 2 times -1, and x of 2, a y of -1, that would be what, -2. So we're going to be a little bit steeper here. And then we've got that whole same pattern where, excuse me, that's a positive 1. So I was at, where was I? I was at 2, -1, which is -2. Okay. So I think we have the hang of it. I'm going to stop using the table and let's just do this like multiplying it in our heads. So this point right here would be like 1 times -2, which would be like -2. So a little steeper than the -1. And 2 times -2 would be -4, which would be even steeper. Okay, how's our very first slope field? We okay? Okay, so we have one, we'll just practice one more. So again, they are hinging on what this relationship is. What is the relationship? What is the dy dx? Okay, that's what we're looking at. So over here, this one's a little bit more complex. We've got more stuff going on. So here, our dy dx is y minus 2x. Okay, so I'm going to start my triple T chart. Actually, I don't even need to write 0, 0 on the T chart, do I? Do y'all see what that would be? If I put a 0 here and I put a 0 here, I'm going to have, 0 minus 0 is 0. So I'm just going to go ahead and let's see what, I guess it doesn't matter what color we use. I guess we'll just use blue. 0. Okay, that one's pretty straightforward. Let's see if we can see some patterns. So if I make x 0, let's think about this for a second. Let's do this. If I make x 0, and let's say y is 1. Okay, so x is 0, y is 1. X is 0 wipes this out. So dy dx would be 1. So my slope would be 1. If I make x 0 and y is 2, then 2 minus 0, that would be 2. Okay? So I'm going to go ahead and keep going along the y-axis. So again, I'm making x 0, y, in this case y would be -1, so we'd be at -1, which would look like that. And then I would be at -2, which would look like that. Okay, we've got the y-axis handled. Let's look at the x-axis, see if that helps us any. So the x-axis, that's where y is 0. And let's look at 1, 0. So when y is 0, x is 1, that would give me a -2. So at 1, 0, I would have a -2. It looks like that. Okay, at 2, 0, what would I have? That would go away. I'd have a -4. Because 2 times -2 is -4. So okay, now let's keep y 0 and let's do -1. That will give me a +2. Just be like that. Okay, we've got the axes done. Are we okay? Okay. So let's work on, I don't know, let's work on 1, 1. So that would be 1 minus 2 times 1. which would be what, negative 1. So at 1, 1, I'm at negative 1. Let's do 1, 2. So that would be 1 minus 2 times 2. 1 minus 4 is negative 3. So this would be even steeper. Okay, there's more going on with this one, a little bit harder. What's that? Let's look. So 1. Did I put it in the wrong spot?
Yeah.
Oh, yeah, I did. I was doing 1, 2, which is here. 1, 2 would be negative 3. Okay, let's do 2, 1. There we go. That's the point that I put there. So 2, so that would be, oh, I see what you're saying. Okay. So here I have 1, 2. Let's look at this one right here. So 1, 2 is right here. Okay. You're not playing nicely with me. That's okay. Okay, so let's look at 1, 2. This is 1, 2. And so we've got x is 1, y is 2. So 2 minus 2 times 1 would be 0. So this spot at 1, 2 would be 0. Okay. So let's look at 2, 1. So y is 1 and 2 is 2. This is the one that was a negative 3 at 2, 1. Okay. Let's see. Do we have any other zeros? What about negative 1, 1? No, that won't give me a 0. Okay. So let's, I'm going to pull some out here because I'm running out of room. Okay, is my arithmetic, y'all know I'm horrible at arithmetic. Is my arithmetic okay now? We good? Yes. Okay, so let's look at 2, 2. I would have 2 minus 2 times 2, which would be, what, negative 2. We've got negative 1, 1. Okay, so y would be 1 minus 2 times negative 1. That would be, what's that, 2, 3. Oops. Then I have negative 1, 2 would give me 2 minus 2 times negative 1, which would be 4. 2, this is 4. Okay, negative 1, negative 1. So negative 1 minus 2 times negative 1. What would that be? 1. Then I have negative 1, negative 2. So we have negative 2 minus 2 times negative 1. There's our other 0. 2 plus 2 is 0. So at negative 1, negative 2, that's 0. This one's a bit of a little stinker, isn't it? 1, negative 1. So we've got a y value is negative 1 minus 2 times 1. Gives me a negative 3. Oops, negative. Then we have 2, negative 1. So negative 1 minus 2 times 2. what is that, -5? Okay, that's really steep. Whew, we're almost done. 2, oops, 2, -1 is here. So I have 1, -2, and 2, -2. Whew, 2 more. Okay, we got this. All right, so -2 minus 2 times 1 be -4. So steep. And then -2 minus 2 times 2, 4, is that -6? So that's really steep. Whew. Okay, so you can see some of them are easier than others. And you see how easy it is to get off track? It is so easy to get off track. So it just will take some time. Okay? Okay, I know you're kind of sad about this, but we're not going to draw any more slope fields right now. We've got some other kind of slope field things to look at. So let's do that here. So the figure below shows the slope for the differential. So this is the slope field for this differential equation. If you wanted to check it out and, you know, put a point in there and, you know, check out the slope down here, you totally could, but that's what that computer generated. Let f be the function that satisfies the given differential equation. So if f is a solution, satisfies the given differential equation, it means it's a solution, right? Write an equation for the tangent line to the curve of f through this point. Okay. Now, to be perfectly honest, we don't need a slope field to do this problem. Sometimes they give us slope fields when we really don't need them. Just so that you know. They are simply wanting tangent line. They want the equation of the tangent line to the position curve. Well, okay, we can do that. We have the point. First we need the slope, right? So dy dx at -1, -2 would be 1 minus -1 times -2. We're just going to calculate the slope of our tangent line. So what would that be? That'd be a +2, so 1 minus 2 is -1. So my slope is -1. And I have my point, right? I love tangent lines. We get to use my favorite equation of the line, y minus y1 equals m times x minus x1. So I've got y plus 2 equals -1 times x plus 1. And again, I got my slope from here, and I got my points from here, where I highlighted in yellow. These are where my points came from, was right here. And that's it. Did we need the slope field? No. I guess they just thought it was pretty and they wanted to show it to us. I don't know. Or maybe they're trying to confuse us and make us think that we need it, but we really don't need it. We could look, if we wanted to, we could see where the point -1, -2, I mean, we could look right here and see what that point on the curve would look like, but we really aren't required to do anything with it. Okay, are we okay? So we can write a tangent line given this differential equation and the point. All right, let's look at this one. Below is a slope field for which of the following equations? So remember how we did all those little slopes? Remember how we did those up there? How we did a t-chart and that's how we created this thing right here? So we're going to kind of go backwards. This is how I work them. There are other ways to work them. What I do is I kind of go backwards. And I pick a point, I don't know, let's pick a point that it really, why don't we do this? This seems like a really nice spot right there, don't you think? What's that? What is that slope? That's pretty clear. That slope is 0. So we need to find which one of these equations, and it might be more than one, and we might have to narrow it down, but we're looking for, at the point, what is that point? Negative 1, 1. The slope is 0. Okay, that's what it is. So I'm going to test this one out. So if I put in, let's see, 1 minus 1. Okay, that's 0. This is a possibility. If I put in negative 1 squared, is that going to be 0? No, that's not a possibility, right? Because that's not going to give me 0. Let's see, if I put in negative 1 plus 1, okay, that's a possibility. What about this one? When I put in, what would this be? It would be negative 1 over 1. Would that give me 0? No, that's not a possibility. And ln of the y value is 1. ln of 1 is 0. Okay, so that's those. I've narrowed it down. This is great. With just one point, we've narrowed it down. So let's look at another location that we want to test this. So now we're working on the 3 of them that are left over. I don't know. What do we see? Maybe let's look at something that's obvious. Like this is a 1, right? This looks like the slopes of 1. Where can I find a good point with that slope of a 1? You'll see a good clear point like 1. It's almost at negative 2. I don't see a perfect one that's lined up perfectly. But we can test it. Oh, here's another. Well, see, that's not perfect. It's so nice when it's right on, like, right on this, the crosshairs or whatever, right there. That's perfect. This is really, really tall. Why don't we try that one? So at 1, 1, we should be like, I don't know, maybe the slope would be like a, I don't know, a 3 or more, or 2 or 3, somewhere in there, right? It's steep and it's positive, somewhere in there. So, okay, I don't know, maybe 2 plus, somewhere. It's going to be bigger than 1. Okay, so if I put, let's try these 3 again. Okay, so this one would be 1 plus 1, and that would be 2, and this would be, that would be 2, and this one would be out. Okay, well, we're down to 2 now. Maybe let's go negative. I'll try the negative 1. Okay, so let's look at negative. Let's look at this point right here. Let's say that is negative 1, and then, I don't know, 1/3. Something like that. Y'all, are y'all okay with that? This one right, this one right here, that I'm circling in the blue, which I guess we'll make it, I don't know, green. This one, look at this one. So that location is like negative 1 and maybe 1/3. Y'all okay with that? And that looks like a 1. Okay, so if x is negative 1, that puts that at 0. Okay, so that one's out. So it's this one. Okay, so the other, well, that is really the easiest way to do it, is to pick points and go backwards from what we were doing. Okay. Are we okay? All right, let's keep going. So here we have the slope for the differential equation. Sketch the graph of a particular solution that contains 0, 2. Label this point as A. Okay, great. So we're going to go here, and we're going to find the point 0, 2. Okay, 0, 2. And they want us to label the point as A. Now, okay, we're sketching the solution. So what we're doing is we're sketching a solution on top of this differential equation. What does that mean? Okay, that means that I'm going to follow the foot. Think of it like a river, okay, with currents. We're going to follow the arrows, however you want to think. So I'm going to start here and I'm going to go up and then I'm going to go down. I'm just going to follow this path. I can be on top of these or I can be right next to them. It doesn't really matter. But I'm just going to follow them. So then looks like we're just going to flow, and we just flow to the very end. Okay, now I'm going to go the other way. I'm going to go this way. I'm just going to follow the curves. We can be on top of them or beside them. It doesn't matter. And this is going to take me out here. And that's my solution curve. So if I were able to solve this differential equation, but I don't even have it. I don't even know where it is. If my initial condition was 0, 2, that's what the graph would look like. Okay, are we okay? So notice how, don't put arrows on it. Don't do arrows. Just go to the end of the graph. Okay, so the next one, this is sketch the graph at -1, -2, and label that point B. So -1, -2 would be right here. We're going to label that as B. And now we're going to, again, follow the little trail. Follow the little breadcrumbs, whatever you will. I don't know what you want to call it, but follow. Follow the way that's going. It's going this way. And then it branches out. Okay, it's coming here. We're following our little trail. You may be surprised at how difficult students find this following the trail business. I'm not really sure, but sometimes students have a very, very hard time with following that pattern. I actually scored one of these, and oh my goodness. I mean, even my students' papers, I've seen students go like straight through like that. Like, seriously? Is that following the curve? Can I ask you that? If I go like that, is that really following the little lines? Is it? No, that is not. It's like breaking through. Okay, we don't get to break through the flow. We don't get to do that. We have to follow the flow. Okay, enough on that. Let's go to our next one. Let's see what they want us to do here. The slope field for a certain differential equation is shown below. Which of the following can be a solution to the differential equation with initial condition 0, 0? Okay. Well, let's plot that point 0, 0. Okay, so we're sitting right here, 0, 0. And so we can draw the curve. Why not? This is what the solution will look like. Oops, stay with me, little thing. Oh, we're getting really steep here. Okay, that's what we're looking like. What do you think's going on right here? What's going on here? What do y'all think? Yep, there's a vertical asymptote right there. So that would be really helpful, right? Which of these have vertical asymptotes? Well, this one does, and this one does. Okay, that wasn't very helpful. They all do. Darn. All right, that's fine. Okay, so we need it to look like that. We need it to look like that. So, again, if we think about let's think about this. Oh, we're going back to pre-cal land. I know y'all are really excited about that. So if I factored this, x plus 2, x minus 2, this one would have a vertical asymptote at -2 like it does. But where else would it have a vertical asymptote? At 2. Is there a vertical asymptote at 2? Nope, so it's not that one. It's not that one. What do these graphs look like? What do exponential graphs look like? Don't they go like that? Right? Is that what that graph is doing? No. Right? It's because it goes like this, right? It goes like that. It doesn't go like this. What does this x do? Do you remember the transformation? What does that do? It moves the x over to the left, right? Because it's plus to the left twice, which is where this is. This is where the asymptote is. It's the left twice. So yeah, that little guy is not possible. So it's one of these other two. And really, I mean, the only work you can show on these is like this kind of stuff we're showing now. It's not like a lot of work. So I'm not liking tangent over 2 plus x. It's really, this is a rational with a, it has an asymptote at -2. It's this one. We legitimately got rid of A and C because, you know, the graph wouldn't look like that. B, we're like tangent over x plus, They do. So what does, let's look at the graph of tangent. So the numerator would look like this, right? The numerator would have these values in them. And the values go like to positive infinity down to negative infinity. The y values do. So what are the chances that, and we could pull out a calculator and check it out, but what are the chances that this in the numerator with, you know, 2 minus x in the denominator would produce a curve looking thing like that? Like not very much. All right, 2 more problems and then we are done. We're trying to give you all the different kinds, well, as many different kinds of these as we can. So we'll be so good at slope fields, so very good. Number 7, consider the differential equation and its slope field. Okay, great. They did the slope field for us. I'm very thankful for that. That was a lot. Describe all the points in the xy plane, and x can't be 0, for which dy dx is 1. Okay, well, they're saying if dy dx is 1, well, why don't we just plug in, and -1 for dy dx and just see what happens. Okay, we want dy dx to be 1, so let's put it in there. And then I get -y equals x plus 1, so y is -x minus 1. So let's see in our graph what that would be. So at -1, we're looking at this. Right, that's the line. So describe all the points. Well, all the points exist on this line, right? Because that's what we just did. We plugged that dy dx in. So this is what we'll just say. So all points where dy dx is -1 fall on the line y equals -x minus 1. Okay, so that's kind of a weird question for them to ask. And we handled that one. We okay? Okay, one more. Explain why the following could not be a slope field for this differential equation. Okay, not for this one. Okay, so we're going to have to think about that. So what about, I really like 0. I don't know about y'all, but I like 0. It's really nice and handy. So let's just say when y equals 0, when y equals 0, what is dy dt going to equal? 0. It's going to equal 0. So let's look at the location where y is 0 is down here. Are all of those slope lines 0? On the x-axis, are all those 0? No, no. So that is, there's a lot of different ways you can explain why it's not, but this is one of them. So we would say the slope of these line segments are not 0, therefore dy dt equals negative 0.3y cannot be the differential equation for this slope field. And you could probably think of ways to say less words than that. Okay, so since this whole thing is the answer, since when y is 0, this derivative would be 0, but the slopes of those line segments are not 0, so that differential equation, dy dt equals negative 0.3y, cannot be the differential equation for this slope field. All right.